Hi, everyone. I'm glad you can join us for this Organic Crops Virtual Field Day. I am Dr. David Butler again, and I'm an associate professor in the Department of Plant Sciences here at the University of Tennessee. And this is part two of my talk in which I'm talking about alley cropping for organic vegetable crop production systems. I also have my email here on this front slide. So if you have any questions, feel free to email me. You can always find me, of course, on the web on the Plant Sciences Department website. And so in these slides, I just want to briefly tell you about a recent study that we have established at the Organic Crops Unit here at UT for alley cropping systems. Our overall objective is to evaluate black locust alley cropping system for potential use in organic vegetable crop production. What we hope to evaluate are vegetable crop yield and quality and disease incidence, carbon, nitrogen, and phosphorus cycling in these systems, microclimate effects of the alley cropping system on the vegetable crop environment, and some soil microbial dynamics, especially the dynamics of some beneficial soil fungi that we are interested in. We have three treatments, the most important being that black locust treatment. So black locust is this tree at the top right. You see a row of black locust trees, Robinia pseudoacacia. It is a nodulating legume, and that means that it forms nodules on its roots for rhizobia bacteria that are able to fix nitrogen. And this legume does have a very high nitrogen fixation rate. We have a second treatment of a non-nodulating legume tree, and that is honey locust, which has a very similar growth habit, only it does not form nodules for rhizobia bacteria to fix nitrogen within the roots of the honey locust tree. And this is honey locust here at the bottom right. And then lastly, we have a control treatment with no trees. And for each of these treatments, we have 4 replicates in the field. This diagram shows you our general layout for this alley cropping design. And now this layout that I'm showing you here is smaller than our actual plots in the field. We actually have 3 rows of trees within each plot and more trees within each row than are shown here. But this just gives you an idea of our overall layout and how we took into account spatial considerations for arrangements of the trees and the crops. So our rows of trees represented here, the larger, what just looks like a shrub, I guess, in this diagram. The larger icons here represent the trees, and these are the rows, and they are 26 feet apart on center. And then each tree within the rows is about 6.5 feet apart, or 2 meters. And so what this allows us to do is to have multiple beds of vegetables between these rows. And so in this case, I've represented if you were doing raised bed plasticulture production, perhaps on 5-foot centers, you could fit within that row fairly easily, between those rows in the alley rather, you could fairly easily fit 4 of these beds. And so that's what I have represented here. Perhaps when the trees are larger and depending on the crops you are growing, it may go to a smaller size, because with 5-foot centers, of course, that takes up 20 feet of that alley. There would only be 3 feet left on each side for buffer under the tree rows. And so as those trees get larger, that area for growth in between the alleys may shrink, just depending on your management of the trees. Lastly, the other thing I wanted to indicate with this diagram is that within that alley, you may also choose crops that are adapted to those different zones. So the green, darker green colored crop here, whatever that may be a crop that's a little bit more adapted to that slightly more shaded environment that would be closer to the tree rows themselves. Whereas the crop grown here in the center may be more adapted to slightly more sun, slightly higher temperatures in that more open environment in the center of the alley. So why did we choose black locust? I already mentioned that black locust has a very high rate of nitrogen fixation as a nodulating legume tree. So with a lot of biomass accumulated each year, that is a lot of nitrogen fixation. In legumes that are nodulating, nitrogen fixation tends to be highly correlated to biomass production. Has very rapid growth, so that's important in getting those benefits that I discussed in part one about from alley cropping systems. So it establishes rapidly. The other thing is that black locust has a favorable leaf phenology for alley cropping systems. It leaves out relatively late in the spring and it drops its leaves relatively early in the fall compared to a lot of other deciduous tree species. The advantage of this in an alley cropping system is if you were to grow cool season vegetables, either in the early spring or in the later into the fall, these are times of the year when there is less light available and the shade cast by the cropping system may be disadvantageous. And so having that late leaf out in the spring and early leaf drop in the fall allows the shading effect to be targeted more towards times of the year when there is ample light, and the shading effect could potentially be beneficial to the vegetable crop. It casts a dappled shade, and because of that leaf structure, those small leaflets that do cast that dappled shade, those leaflets also decompose fairly rapidly. They're not going to cause issues with accumulation underneath the trees. It is a marketable wood species, most well known in the eastern US for its use as a naturally rot-resistant wood. It was used a lot in fence post applications and other applications where long life in wet or outdoor conditions would be favorable. In organic systems, of course, it is an alternative to using treated wood posts for fence posts, which would be prohibited in organic production systems, but would have a similar lifespan to those treated posts as an untreated wood species. And it's native to the eastern US. Temperate climates generally have fewer options for nodulating legume trees that could be used in agroforestry systems compared to the tropics and the subtropics. But black locust is one, and it is native to this region. Another one that possibly could work well, but is not native, would be albizia, often called mimosa or silk tree, which is widely naturalized in Tennessee, but is not native to Tennessee. Honey locust, as I mentioned, is our non-nodulating control. It does not form nodules on the roots. I'll just say that its relationship to rhizobia bacteria is unclear. Honey locust, of course, lives in similar environments as black locust. It's often seen as an early successional species, often does well in poorer soils. So it still does well in similar conditions to black locust, but it is non-nodulating. Lastly, I wanted to talk just a little bit about establishment of the trees. I think it's important to plant dormant trees in fall or early spring. When we established this spring in spring of 2020, we were unable to get the trees until well after the COVID-19 virus had been causing issues in the United States, and that delayed our tree shipment even further. So we were not able to establish until early April. That's a little late. They still established okay, but that's a little late because the trees do not have time to establish before you get into some of those droughty periods that are common into late May through the summer in Tennessee. Bare root trees are generally available for black locust. 1 to 2 foot trees, bare root, are available for $1 to $2 each in larger quantities. I think over 100, perhaps you could get them at $1 per tree, but at lower quantities, of course, the price generally increases. It can also easily be propagated on your own if you have a source, or you could easily find a wild source of seed from black locust trees and propagate the trees. They do grow rapidly. Weed management is one issue early in establishment. We've been mowing to maintain low weed pressure, and you can see here at the right, these are some of the black locust trees, a portion of the row in one of the treatments of black locust trees. These were planted in April, and this is in August, already several feet high. So it is a rapidly growing species. And so they are very favorable because of that rapid establishment. And then lastly, you may want to implement some tree protection as you think about different weed management options. If you're using string trimmers, of course, they could easily damage the trees. There are ways to protect the trees from that. Also, some may want to establish the black locust trees in a system prior to vegetable crop production where they might use grazing in those cases as well. The trees would need to be protected. Black locust is a very favorable browse species for a lot of livestock because it is a legume with high nitrogen content and high protein content. I just wanted to list some resources on this last slide. First, the Association for Temperate Agroforestry, then the Center for Agroforestry at the University of Missouri, the National Agroforestry Center, which is part of the USDA, and then lastly, a resource from the UK, which is the Organic Research Center, which has a lot of resources available online related to alley cropping systems and agroforestry systems in general. That is all I have for you. I hope you've enjoyed this presentation. And again, please do send me an email if you have any questions.